Hi, Mr. So today I'll be doing an experiment about force. I'll be using a simulator. So the conceptual theory in this experiment, I will use force as my main topic, and one of the objectives is to test out the force and testing the formula. Whereas a seesaw is used because it is the type one lever, and by using it, we can also determine the principle of moments, which is clockwise and anti-clockwise. And the formula for this topic is F1 times D1 equals to F2 times D2. The objective is to determine the force acting upon it and to determine the principle of moments as well as to count the force acting upon the seesaw. The materials needed if you are going to conduct the experiment live, you can use seesaw, a real seesaw or a board and a pivot in the middle, a ruler or any measuring device, and any kind of object to add the force to the seesaw. So I took my simulator from this website, PHET Colorado Education. I have inserted here. Okay, so first in here, let's just consider that the bricks are in Newton instead of kilogram. So on the left side, we have 10 newtons of brick, and let's assume that the distance is 1 meter from the pivot. The pivot is the yellow thing in the middle. And on the right side, you have 15 n of bricks with the distance unknown. So in here, we're going to find T2. The formula is F1 times T1 equals to F2 times T2. Okay, so F1 is 10 n times 1 meter equals to 15 n times T2. So it will be 10 n times 1 meter over 15n equals to D2. So D2 equals to 0.6 meter. So this is D2, and let's check using the uh, ruler, yeah, the ruler. In here, the position is 0.5, so it's about the average of the distance. Then the second one, we have 20 n of brick in the left and 20 n of brick on the right. And if we remove these silver pillars, uh, they're going to be balanced because they're both in the same. They both have the same uh, force, and they're in the same distance, which is 1.5 meters. And this is when the seesaw is on its equilibrium point, and as I've written in the theory, the seesaw is in its equilibrium position, the sum of clockwise must be equal to the sum of anti-clockwise. So they are equal. And the last question, we have 30 kilograms, 30 n of people on the left, of a girl on the left side, and 20 n of a boy in the right side. So let's assume that the known one is 30 n, which the distance of the girl to the pivot is 1.25 meter, as well as the boy is 20 n, and the distance is unknown. So we are going to find D2 again. Uh, so it will be 30 n times 1.25 equals to 20 n times D2. So 30 n 5 over 20 n equals to T2. So it will be 1.85 meter. So let's check using the ruler option. So it's 1.75. So more or less they're similar. And the last objective is to determine the principle of moments. There are two principle of moments, which is clockwise and anti-clockwise. It's actually depending on the position of seating. So if you sit on the right side, then it will be clockwise, and on the left side will be anti-clockwise. So it all depends on the position of our on where we sit. Okay, so um, this is the experiment data that I'm going to use for math. In conclusion, to find the force and distance, the formula is well used, but it needs at least three known numbers in order to be able to find the questions. Also, when it is at a moment of equilibrium, it means that it is equal, both forces and distance. So it's all equal. And clockwise and anti-clockwise depends on the sitting position. So I think that's all that I can give for my um, experiment and presentation. I hope I could deliver my presentation well and it could be pretty easy to understand. So, thank you.